My name is Wayne Beaton, and I'm the Director of Open Source Projects here at the Eclipse Foundation. In this video, I'm going to present the Eclipse-License tool. The Eclipse-License tool is intended as an interim solution while we plot a more extensive reworking of the Eclipse Foundation's IP due diligence process. The Eclipse-License tool is a tool that is intended to help Eclipse committers assess the license status of the content that their project leverages. I'll take this opportunity to reinforce that it is a tool. It is just a tool. The tool really only knows what you tell it. While it does have some rudimentary functionality for rooting out content, we very much depend on committers, who form the first line of defense in our intellectual property due diligence process, to understand the content that their project contains and leverages, and to ensure that all content is identified and fully vetted. I'll state this a couple of times. The tool is intended to assist. It is not the authority. It's worth noting that the Eclipse-License tool is intended for technologies that have some notion of package management. That is, it is intended for technologies that have a means of identifying specific components and specific versions of those components. Moreover, it is intended for technologies that have well-known package managers. This includes technologies like, for example, Maven, which has Maven Central, or NPM, which has NPM.js. Unfortunately, this leaves out random bits of third-party JavaScript content that's integrated with project code and pretty much anything that uses builds based on make. Here I'm showing a bit of the dependency tree generated from a Maven build. Some technologies generate a dependency file. In the NPM world, for example, we have package lock and yarn lock files. In Go, we have go.sum files. We can use the output these tools generate to identify very specific versions of very specific components. In many cases, we can also identify very specific sources for those components. In the Maven context, a GAV, or the aggregation of the group ID, artifact ID, and version, describe a very specific artifact that we can pull out of a repository like Maven Central. Of course, the various technologies represent their coordinates in very different formats. Maven has GAVs, NPM.js coordinates employ a slightly different format to combine an optional namespace, name, and revision of components, which are expressed in the package lock or yarn lock files. So we depend on the various build technologies to produce a list of dependencies. The Eclipse-License tool takes the list of dependencies as input, however it is generated. It then checks with the various sources of information that we have available to identify licenses of the content in that list of dependencies and generates a sort of bill of materials that maps the individual bits of the content to the corresponding license. The Eclipse-License tool also highlights the content for which it cannot identify the license, or the confidence of the license is low, or the license is either not compatible with the project license or is otherwise problematic for use by an Eclipse project. Committers must engage with the Eclipse Foundation's IP team to resolve the outstanding issues, and the IP team feeds what they learn in their investigation back into the system. In cases where the IP team identifies content for which license compatibility cannot be resolved, they will work with the project team to mitigate. Very often this requires that the project team research alternatives, but the IP team does have some other options at their disposal. We'll save that discussion for another time. The process may be iterative. At the end, the hope is that we wind up with a complete accounting of all third-party content under compatible licenses. Note that we currently use two sources of license information. Our primary source is our own database, lovingly referred to as IPzilla. The second is the community-supported, clearly defined project. The Eclipse-License tool comes in two different flavors, a command-line interface and a Maven plugin. In this example, I'm showing the Maven plugin being used on a project's repository. The plugin uses the information that Maven itself gathers regarding dependencies as a starting point. It attempts to find vetted license information for each dependency. Remember that the tool is only as good as the input that it's given, so as long as Maven knows about the dependency, the tool does a pretty good job. I have noticed that we sometimes have to do a little digging with Eclipse Tycho-based builds. The command line version of the tool knows how to deal with package lock and yarn lock files. as well as files that contain lists of arbitrary content. It's possible, for example, to pipe the output from Gradle through grep to get a list of dependencies, and pipe that directly into the tool. The Eclipse-license tool's Git repository README has numerous examples of how the tool can be invoked on various technologies. As the tool continues to evolve with help from our community, we are currently investigating, for example, support for pulling dependencies out of a GoSum file. As new features are added, we're keeping the README file up to date. You can find more and current information there. Many different technologies have many different ways of identifying content. Many, perhaps most, Eclipse projects use Maven or Gradle in some manner. Maven uniquely identifies content by GAV, or group ID, artifact ID, and version. In fact, content is further identified by its source. At least potentially, content in one Maven repository, say Maven Central, could have the same GAV, but be different content in another Maven repository, say repo.eclipse.org. Golang generally, but not exclusively, uses a combination of a GitHub repository location and a version. npm.js uses a variation of PURL to identify content in its repository. Content in npm.js may be different from content in Yarn package. Clearly defined IDs combine the type and the source of information with specific coordinates. To be sure, it has some deficiencies. For example, Maven classifiers are not considered. Here's an example of the command line version of the tool being invoked on a Yarn lock file. In this case, the tool has identified some content for which it cannot find vetted license information. I've added the review switch and have specified an access token in project ID. This feature automatically creates review requests that are automatically scanned. In the event that the vetted license information cannot be identified, the IP team will engage. You need to get an access token from Eclipse Foundation's GitLab instance to use this feature. Do not share your access token. This feature depends on various conventions to identify the location of source archives. It currently supports content retrieved from Maven and npm.js, and there's ongoing work to support the Golang repository, Yarn package, and more. At this point, however, I should reiterate that the Eclipse-license tool is intended as an interim solution while we plot a more extensive reworking of the Eclipse Foundation's IP due diligence processes. So the Eclipse-license tool itself is open source. It is a component of the Eclipse project. It's hosted on GitHub. Please do when you identify issues with the tool, please do report those problems using the GitHub issues directly on the repository. There is a discussion channel there if you have questions that need to be answered, and of course pull requests are welcome. As with anything else IP related, if you have trouble or need some help, detect some shenanigans going on, and need some help understanding how to resolve third-party dependencies or something else, please just send a note to emoipteam@eclipse.org for assistance. The repository link for the license tool is shown here. Thank you so much for your attention.